Yeah, so in today's class we shall be learning about the Python list in much more details. Okay, we know already that we can declare a Python list simply by specifying the values separated by comma in this fashion. Okay, and if I write print a, it's going to print the list, that is 1 2 3 4. We also know that Python supports different data types. Say for example, we can have a string, let's say a character and a hexadecimal number. So Python supports having a list of different types of variable. As you can see over here, and we can access the individual elements just by giving their respective index, where index is between 0 to n minus 1. Let's say a of 0, which is 1. If I say a of 0 plus a of 0 1, I mean this is 0 1 2 3, a of 3, what happens? It is 565 because a is 1, hello a, 0x, hexadecimal 234 is equal to 564 added with 1. On the other hand, if you just try to do a of 0 plus a of 1, let us see what happens. It generates an error, which means that Python list supports different data type, number 1. Number 2, it retains the data type in the list. So if the list contains similar data type, sorry, the operation is allowed on the data type. Now, print, let's say, operations on list data. Now, the next thing is that we should be able to add an element into the list. Okay, so you can simply add an element by append, say 8. After appending a is equal to so as you can see, after appending a will become 1 hello a 564 8. I have appended a value 8. Let's append one more value, say 69. Let's run it. So a will contain 564 869. So what we learned, that by using the append command we can append new data at the end of the list. So whenever you use append command, the data is added at the end of the list. Now, what if I try to append multiple variables, multiple data? So let's say a dot append. Let's take one more list, say 100, 200. Now when you do this and print, let's copy this and keep on modifying. So print after appending a list in A becomes, in A becomes 1. So now this is what you need to understand, that if you try to append a list with a list, it will become that particular data will become a list in itself. So if you try to print, so this is 0, 1, 2, 3, 4, 5, 6. So length of A, however I have appended 2 elements. Now if you try to print length of A, it's going to show 7, not 8. I basically have 8 elements. However, the 7th element, that is index number 6, in itself is a list. So if you try to print A of 6, it is going to show 100 and 200, and if you write A of 6, 0, it's going to show 100. Okay, so you can have a list of lists or list of lists. So whenever we use append command, Python is going to append the variable at the end. If the data that we are going to append is in itself is a list, Python is going to retain that list. But what if I do not want to have a list, rather I want the element to be added flat at the list? Okay, so I do not want the length to be 7, I want it to be 8. I do not want 100 and 200 to be list, I want it to be part of the same list itself. So in that case, Python gives you one more command called extends. We have appended. Let's again test the extends command. After, let's see extending. Instead of append, let's use extends. Okay, and instead of 100, 200, let's put 300, 400. Because this is a list, we can use a hybrid data type also, hello, something like this. Now once you run, this is extend, not extends. Extend, the command is extend. So you can see 1, hello A, 564, 869. 100 and 200 becomes one more separate list, but 300, 400 and hello becomes part of the same list. Okay, so using extend command, we can add data. Even if the data is in a list, the element will be extracted and put it into the parent list. So this is the difference between append and extend. However, thing to be noticed here is that in both the cases, the new data is always added at the end of the list. Now what if I want certain element to be added at specific position? So see, in order to be able to add certain data in a specific position, you can use insert command. I have given index number 0. So if you observe the list over here, 0th value is 1, first value is hello. But instead of hello, now the first value becomes 30 and hello and all the other thing is pushed back. Things to be remembered is that you can use a blank data or a null data, you can append it in a Python list. For instance, let's say inserting in specific place. Let's say a dot append null. Let's see, after appending null, so you can see once you append null, it puts a blank data. Now you need to pass some data in some ways. You cannot keep the append command blank because it expects one parameter. So either if you want to append null, you can have a null list, or it's a blank string, in whichever ways. Okay. Now even if you put null, it's going to take it because it's going to put everything at the end. However, in the insert command, if you try to insert at a location that does not exist, for example 19, the array doesn't have, this list doesn't have 19 elements, so 19th position is invalid position. So let's see what happens. Yeah, after inserting A in a list. Now let's see, you have given position number 19, which doesn't exist. Okay, so what it's going to do is that if it doesn't exist, it's going to put it absolutely at the end. It's not going to generate any exception. So insert command can be used to put an element at a specific place in the Python list. You can also use a random big number to use insert command just like an append command. Now, what if I insert a list in Python, say 30, 40, in second position? Now, if you observe this, the insert command will act just as append command. Okay, and it's going to put that element in the specific position. So I have given second position 0, 1, 2. In the index number 2, the value becomes 30 and 40. So insert is just like an append command with the possibility for you to provide an index. What if I specify -1 in the index during the insert command? So see, once you specify -1, this is going to be inserted absolutely at the end. Okay, so where is it? Insert command. Yeah, hello 564, 100, 200, 30, 40. Where is 30, 40? Yeah, that is second last place. -1 will be second last place. If you specify -2, second from the end, so this is same as specifying length of A -2. Okay, so which means that in Python, if you want to put an element from the front, that also you can do. If you want to put an element from the back, that also you can do. So all these are possibilities as far as the insert is concerned. So we can use insert, append and extend to add element to the list as per the appropriate choices. Right. Now let's take a completely numerical list. Let's say A is equal to 1, 2, 3, 4. If you want to delete a specific element, we can say delete A of 0. Let's say after deleting from list, A becomes 2, 3, 4. So 0th element is been deleted. So 0th element has been deleted. Instead of that, if you say, let's put it 11, 12, 13, 14, so that we don't have any confusion. If you say position number 2, 0, 1, 2, 13 will be deleted. Okay, 13 is deleted. It will have 11, 12 and 14. Now, what if I try to delete -2? 11, 12, 14. Why? Because this is the end element, this is -1 element, this is -2 element. So insert and delete both supports specifying. See, this is the difference between Python and say some programming language like C program. In C program or in .NET or in Java or most of the other languages like MATLAB also, if you specify a negative index for the array or the list, that's going to give an exception that the index doesn't specify. But in Python, the index, negative index, suggests that you have to read the value from the end. Now, what if I try to delete an element, say 12? You'll see that it's going to generate an exception. Remember, in the case of insert command, if we had specified an index that doesn't exist, the insert automatically inserts the element at the end. However, when you try to specify an index for the delete command, when it doesn't exist, it's going to raise an exception. So whenever you use delete, it's always a good choice to put it in try and except block. So, list assignment index out of range, okay, that is generating an exception. If you however give this command, okay, now there is one more way of deleting a specific element. Instead of index, if you know which element to delete, you can use a dot remove that specific element, say for example 12. Print after deleting 12 from A is equal to so you see in delete command, after delete we are specifying the list, in the index we are specifying the index which we want to delete. However, remove is a method which corresponding to the list class of Python. So for remove, insert, append, we can directly call them with respect to the list variable name. A dot remove 12, it's not removing the 12th index, it's removing the data value which is equal to 12. Let's see, 11 and 14, because 13 we had removed at this stage, 12 we have removed at this stage. What if we specify something which is not there in the list? Say for example 100. 100 is not there in the list. X is not in the list. So it's always a good choice to keep both remove as well as delete command inside try block. You can use different exceptions, or you can put them inside single try and catch based on your requirement. X is not in the list, so instead of that, if I specify 11, okay, list becomes 12 and 14 because 11 and 13 are removed. Now we have already learned in the while studying about the Python functions that Python functions always return something. Even if it is null, even if you are not returning anything, it returns null, right? So obviously, because remove is a function which you are calling, it should be returning something, right? Let us catch that value. Let us try to see what it is returning. Okay, let's say r is equal to a dot remove. Return value r is equal to 1 a comma r. So let's say while deleting an element, what it removes. Okay, r is none, which means that remove command returns nothing, right? But sometimes we may require to know, sometimes we might require to know, which element is deleted. And just like the append command, see here in both remove as well as delete command, we need to specify a data, right? So in delete command we are specifying the index, in remove command we are specifying the value itself. In delete command you can also specify the array's data, that is a of 0. This is also allowed, right? Now, but you can see that everywhere we have to specify some data. Just like append, which automatically appends an element at the end, Python also supports you to delete something from the end. Let's say print a, this is my list now. We can have a command, say a dot pop, and let's take the return variable. After popping, all of them is indented, so they automatically become part of the except block. So the list was 12 and 14. After popping, a becomes 12. So you see, pop command will delete the element from the end, right? Return value is 14. So pop command will not only delete the element from the end, but is also going to return the element which is being deleted. So pop is part of something called linked list. We know the operation, that push and pop operation. Okay, it's related to stack. In the stack we push the element and then we pop the element. However, thing to be noted here is that Python list only supports a pop command. It doesn't support a push command. So if you try to ever write a dot push, say 8, let's see what happens. It gives a message, instance of list has no push member, which means that even though this is a list and Python supports a pop command which picks out an element from the end and returns that element, it doesn't support a pushing. So for pushing the data, you have to use either extend or append, or you need to use insert command, any of them. So we have 3 ways of inserting an element, that is insert, where we can insert an element at specific instances. That instance can be either from the front or from the back. If you want to insert something from the end, you have to use negative indexes. Python supports negative indexes, which means that it is from the end. Other programming languages like C, C++, Java, MATLAB, they don't support negative indexes. It's always raise an exception called array out of bound exception. Similarly, just like insert, there are three ways in which you can delete an element. You can use a del command. When you are using a del command, you need to specify the index value which you want to delete. For remove command, you want to specify the element which you want to remove. That element can also be specified as array of that specific index. You can also use a pop command to remove from the end, right? Okay. Now, so we have learned the Python list, insertion and deletion. Let's now try to understand how to loop through a list. Okay. So let's say A is equal to 1, 2, 3, 4, 5, 6. Okay. So usually in C, C++, whatever, we just write for I in range 0 to length of A, print A of I. So it's going to print all the element one after the other. If you want to print the element one after the other, you can also print the element with this command, or you can write Now, what if I want to print every two numbers, right? Let's say print, let's say direct printing. Okay. Now, what if I want to print, or I want to take list 1, 3, 5, 6. So I can give in the steps of 2, right? If I give in the steps of 2, it's going to print 1, 3, 5. 1 after that 2 will be added with the index. So it is index number 0. 1, index number 2. With index number 2 again 2 will be added, index number 3 and index number 4. So 1, 3, 5 it is printing. What if I want to do the same thing with direct access? So you can write A of 0 to length of A in the steps of 2. Okay. If I want to print in the reverse order, what am I going to do? I am going to write length of A minus 1 up to minus 1 in the steps of 2. So 6, sorry, so A minus 2. So 6, 4, 6, 4, 2. What if I have to do the same thing over here? In order to do the same thing over here, again, length of A minus 1 in the step, up to minus 1 in the steps of minus 2. So whatever range you specify, so in order to print the list from the reverse or accessing the list from the reverse, you can write -1, which earlier case, in the case of insert command or delete command, we have seen that -1 suggests the last element, from -1 to 0 the first element in the steps of -1. So it's going to print everything. You can also use -2, now 642, here also 642. Now Python gives you some great things. Suppose I write :2. This means that Python is going to print the list up to second element 0, 1, 2. So you see 1 and 2. 0, 1, 2. Second position has the value 3. So if you give :2, it is going to print only up to the second element. If you use the colon after the index, which means that after the index number 2, whatever is there, it's going to print that. So starting from 2 to whatever values is there till the end, it's going to print. Now see the difference. If you give :2 up to, that is before the second position, before position number 2, it's going to print everything. But if you give 2: starting from second position up to the end, it's going to print everything. You can also specify a range 2 to 4. That means 0, 1, 2. This is this element. 3, position number 3, position number 4. So 3, 4, 5 is going to print. Up to 4, that is 2 and 3. This is the fourth position, because whichever is there after the colon, it's going to print 1 before that. Okay, so 2 to 4 will be printing starting from 2 up to position number 3. So if you give 2 to 5, starting from position number 2 up to position number 4. Okay, the same thing with the for loop. If you want to use, you need to use I in the range 2 to 5 in the steps of 1, or just simply 2 to 5. 3, 4, 5, 3, 4, 5. Okay. Now this is how we can access the element in the forward order, reverse order, in whichever way you want, using this kind of indexing. Now why you would prefer this kind of indexing is because instead of using for loop, we can use this index for a wide range of operations. For example, m dot, we have already imported that, m dot mean. So you don't require to import maths. Sum is a direct command in Python available with the base package. It's going to print that. If I say sum of a, the entire thing is going to be printed, the added. If I say a of just up to 2, 0, 1, it's going to show 3. Okay. If I say 2 colon, that means starting from 3, so 3 plus 4 is 7, plus 5 is 12, 18. It should print 18. What if I want to add some values with all the elements? Let's say, so we are doing some mathematics on Python, right? We want to add some elements, that is, say with 1 I want to add 10, with 2 I want to add 10, with 3 we want to add 10. Now in MATLAB, if we write a is equal to a plus 10, 10 will be added with all the elements. Now let's see what happens in Python. You'll be surprised to see the result. See, type error can only concatenate list, not int to the list, which means that if you use this command, your result is like this. So you can also use plus to append an element to the Python list. What if I use this command? So see, Python doesn't support minus command. If you use plus command, the data will be added, but there is no equivalent minus command. Most interestingly, if you use a multiplication, however, let's see what happens. The list will be doubled. Let's shift back to our Jupyter notebook instead of REPL.it. Let's say is equal to 1, 2, 3, 4, 5 and 6. If I say a is equal to a plus, let's say 20, and we know that it gives a type error. So whenever you want to have 20 added with this, you have to place it with list. So it's going to add 20. What if I write 20 comma 30? So the plus operation acts like an extend command in Python. So instead of extend, you can just write plus. We also know that there is no equivalent minus, just like plus, there is no equivalent of minus. So if you want to remove the element, you still have to use the remove command only. sorry, because plus will not be adding this as a list, rather it will extend it, cell, run cell. Now it will have one, sorry, 20, cell, a of 0, 1, 2, 3, or let's just write a dot pop. So from the end 30 is removed. What if I use a is equal to a into 2? What happens is the list is concatenated 2 times. If you use 3, it will be concatenated in 3 times, but there is no equivalent of division. So in Python, list plus will act like extend, will put the elements that you have specified, and multiplication will add as concatenated addition. So number of times you try to multiply the list, that is going to be multiplied with itself. Now in many cases we might want to have an operation on the values. Let's say, let's run this cell, run cells. Let's remove the pop command also. So we have 1, 2, 3, 4, 5, 6, 20. Instead of that, what if I want a result of 21, 22, 23, 24, 25 and 26. If I want to add 20, what I need to do? You can click. What you need to do is import numpy as np, make a is equal to np dot array a. So you are converting a Python list to np array. Then you can write a is equal to a plus 20. Let's see. Okay. What if you specify this as a list? So if you run this, still it is going to take this as a number, not as a list. It has not appended 20 at the end. The earlier value cells, run all the cell, run all if you do, 21, 22, 23, 24, 26 and 40. So once you convert something into numpy array, you cannot you can perform the numeric processing. So plus and minus becomes a is equal to a minus 30. Okay, so plus and minus will have their own meaning, right? You also have a is equal to a into minus 4. So if you have, it will be multiplying everything with minus 4. You can also write a is equal to a divided by 4. these are the values. So which means that once you convert a list into a Numpy array, you can perform mathematical operation, and these are all going to be scalar operations with that. Okay, what if I write np dot array 20? What if I write np dot array of 20? You see, if I specify 20 directly, this is like a list, right? Cell run all. So whether you use it as a list, okay, if their size is not same, it is going to extend this, okay, and it is going to perform all the operations as it is. Just see, cell. Okay. However, the size of this array is 1, 2, 3, 4, 5, 6, 20. But here the size is only 1. What if you take a list of 20 and 21? Now you see, only if your operand has one element, it is going to be virtually extended into n number of elements that the other operand has. But if it has got more number of operands, then you need to have specifically same number of operands, I mean specifically same size of array in order to perform the scalar operation. 1, 2, 3, 4, 5, 6, 7, 20, 21, 22, 23, 24, 4, 25 and 26. Cell run all. Now it is allowed. Or else, if you want the same number to be added with something, just specify it like this. You are most welcome to not even specify this as a list, but just write 22. And this is true for any variable also. You can declare x is equal to 12, which is a linear variable, and you can write a is equal to a plus x. Okay, so here in notebook, remember, cell run cells. When you do, only this particular cell is going to be executed. If you see run all, from the starting everything is going to be executed. Okay. Now once you have converted the list into an array, this is an NP array, right? What if I write you see, np.nd array object has no attribute called extend. So if you want to keep continuing with the list, you have to convert a back into list. You can do that simply by using a is equal to a dot to list. The toList method of Numpy array will convert that array into Python specific list. Okay, and you can use it has become like a list. Okay, so what we mean to say is, whenever you want to perform certain numeric operation on any Python list, you can convert that into NP array, perform the operation. If you are interested in doing some matrix operations like vector multiplication or transpose of a matrix, stuff like that, you can convert it into a matrix, and once your operation is completed, you can always convert it back into the Python list. Now, so we learned how to perform once you have converted it into see cells, insert cells above, okay, sorry, cell, insert cell above. So before converting it back into the list, let's delete this cell. We can also write okay. So whatever operation is supported by your Numpy array is going to be supported by this also. You can also write sum of A. See, sum is Python's support, okay. So Python, okay, so Python can take list as input, Python sum or mean can take list as input, or NP array that is Numpy array also as input, and it can support the operation. So we can use mathematical operation in both the cases. I suggest you, whenever you have to use some mathematical operation on a list, it's better to convert it into a Numpy array, perform the operation, because you have an option of converting that array into the matrix also. So perform the operation and put it back into the list format by calling the toList method. So even though some basic operations is supported by this, we suggest you to follow this process of converting this. Now while converting it into NP array, you can also write A of, okay, so cell run all. You can also specify how many elements you want to turn into an array. So 1 to 2, obviously starting from 1 up to 2. So first element was nothing but 0 1. What was it? Was 0. Okay, 0, yeah, 1 position is 2. No, what we are going to do is up to 4, let's take cell run all. So we are adding 12 with this. Let's make x as 0, cell run all. So 2 3 4, only this much portion is going to be turned into the array. And so if you want to take a part of the list, this is also called slicing. You can use this operation and you can perform this slicing, and it also supports the other way around. So if you give A of -1, cell run all, only the last element, okay, if you say -1 to 0, in the steps of -1, okay. So whatever operation is supported by list, slicing or accessing the indexes, can also be performed while converting it into an NP array. Up to -1 to 0, 0th element is cuttled down here. Cell run all, starting from -1, actually 0, cell, well, converting this is leaving out the 0th element. So this is -1 up to 0. If I specify 1, even 2 will be left out. Can only concatenate list, not integer.
remove that a plus 2.
So that's
Adding
it's okay. We have concatenated one element. This is inserted. A of minus 1 to 0. Yeah. A of minus 1 to 0 in the steps of minus 1 run all. Okay. If I specify minus 2 to minus 1 cell, there is no minus 2 to minus 1, it cannot. So minus 1 to 0. So one of the drawbacks of this, I just realized it. No, it's just that with this method the 0th element is going to be left out. So it's always better to take it in a different fashion and then convert it into the array. So this is how actually we can take a list, access the list, and we can convert it back into NP array. Now there are some more operations on list. The Python list support Boolean operation. Now the list value is 1, 2, 3, 4, 5, 6, 20. Let's add number like 1, 1, 2, 2, 2, 3, 3, 3. Say b is equal to 1 in a. So if you write 1 in a, it means that it's a Boolean operation which checks whether variable 1 is present in a or not. If I say 99 in a, cell run all, it is not present. So because this is a Boolean operation, you can use it in any logical statement. Else print data is absent. Let's declare x is equal to 99, and instead of 99 let's check for x. So cell run all, data is absent. If I make it 2, cell run all, data is present. So x in a is a Boolean statement. We can also write print number of in list is equal to, so you can count number of certain element in a list simply by A is 1, 2, 3, 4, 5, 6, 1, 1, 2, 2, 2, 3, 3, 3. Number of ones in list is equal to 3. So we are declaring one variable, and we can use a dot count. A dot count is going to return the count of a number of variables. So instead of variable, we can specify, let's say 2. So now it is going to count number of 2's in the list, and it is going to return cell run all. Number of 2's in the list is 4. 1, 2, 3 and 4. Okay. Now what if x is equal to something which is not present in the list? Number of hundreds in the list is 0. So if it is by using the count command, we can count the number of occurrences of certain value in the list. Similarly, the index command is going to return the first index of all the elements. Okay, so let's add a new cell. Okay, so index of in the list is, so x comma a dot index of x. Let's keep x is equal to 2. Cell, let's say run all. List is 0, 1, 2. 2 is appearing at which position? 2 is appearing at position number 1. Okay, 1 is appearing at 1 will be appearing at position number 0. Cell, run cells, index of is it index is, it should show 0.
In 6th place also 1 is there.
That's fine, but it should show the first instance. X is equal to 3. Okay, let's say cell run all. Yeah, list is 0. So again, if you print once more, let's see, cell okay, so it's going to return the starting position of the value 1 in the list wherever it appears. So by using the index command, we can find out where exactly the element is located. What if I give 100? What index it should show? Now it is going to generate an exception, cell run all. You see value error because the index doesn't exist. So it is always advisable that you use, while using the command, index inside a quote. Okay, so directly the exception is going to be showing like this, and if you give anything else, right?
It should show the index of 1 in 0th position and 1 more is in 6th position and 7th.
No, I'm coming to that now. So index command is going to return the first index of occurrence of your data. Now what if I want to know all the indexes of the occurrences of certain data in a list? So what we are going to do is, so in case if we want to find all the indexes, what we can do is a is equal to np dot array a. Okay, now index is equal to a dot where, sorry, np dot where a double equal to x. Let's say x is equal to 1. Let's say x is equal to 1. Print index, cell, run all. You see, it's an ND array with value 0, 6, 7. So whenever you are at 0th position there is 1, 6th position there is 1, 1st position there is 1. However, it returns a key value pair. So in order to remove this kind of result and get it as a array only, you need to write it in this fashion. Okay, so np dot where a is equal to x 0th element dot to list. On the other hand, instead of converting this, if you write a is equal to x, what happens? Cell, run all. It is not going to return anything because a is now a list, not an np dot array. So this is called inline conversion. So you can convert measure, okay, and a is still and list only, still a list only. So a dot append 30 you see, a is appended 30. On the other hand, if you had written this statement and you had assigned this into a, oh sorry, okay, because now a is converted into an np array. So wherever you wherever you are doing the coding, when you are new, always convert it into np array, perform the operation, put it back into the list and proceed ahead in order to remove the confusion. Or simply if you do not have to store the element, or if your work is converted in a single way, now you see I am not removing a is equal to a dot to list, just to see what happens. So a list can always be converted into to list. It is never going to raise any exception. Okay, so np array can be converted into list, or already existing list can already be converted into the list. So this is where we can find out the location of multiple elements. What if we specify something so therefore instead of using index command, it is always better to use np that is numpy to find out the positions, because then we can write length of index. So I'm trying to find x. I'm getting all its position in index. If I take length of index, total number of occurrences also I can get. So instead of using count command, you can also use this method. Total number of occurrences of 100 in the list is 0. If I use 1, it will show their position and totally how many number of times. So instead of using count command, you can also perform the operations in this way. Okay, so this is about our